Okay, so technically these concepts go all the way back to 4th grade for you, and you think, okay, self, how do I multiply fractions together? And the way you multiply fractions together is you can either simply multiply everything together and then cross out and cancel later, which for polynomials is a terrible idea, or you should go back to your roots of 4th grade and say, I could cross cancel. Now cross canceling requires you to have factors that are already in factored form for polynomials. So like this factor right here, you can take an 8 out of that, and you get 8 times a minus 8. A minus 2 does not factor any further, so I'm just going to leave it. But notice how I put parentheses around it? Here you can take a 5 out, so it's 5 times a minus 2, and then that second denominator you can also take a 5 out. And you get a plus 3. So now you can do that cool technique from 4th, 5th grade where you did cross-canceling. Anything that exists on the numerator and denominator as separate terms can cancel each other out. So like for instance, these 5s cross-cancel. Anything else cross-cancel? The a minus 2s cross-cancel. And then that's it. So your final answer is, leave it in factored form, please. 8 times a minus 8 in the numerator over a plus 3 in the denominator. And this is usually in Algebra 2 where kids would get sassy with me and they'd tell me, oh, you should cross off those a's. And I would tell them, there is not an a in that question. There's an a minus 8 and there's an a plus 3, but those are two different numbers. All right, skip ahead to number 3 with me. This time we're dividing fractions. So remember, you can't actually divide fractions. Your 4th, 5th grade teacher made you change this to a multiplication problem, because you're going to reverse the second fraction and rewrite it as the reciprocal. But same rules apply, guys. You can only cross-cancel things that are factored. So factor everybody that factors. So everything I'm boxing in red is going to factor. This is going to be fun. All right, so this first one, 7r squared plus 70r. There's a common factor of 7r that we're going to take out. And then we're left with r plus 10. That first denominator doesn't factor any further. It's just the quantity r plus 5. I like to put parentheses around those quantities. You don't have to, though. Remember, we're switching this to a multiplication problem because we're going to flip this fraction around. So this now becomes my numerator, and I have a common 8r squared you could take out. So that leaves me with r plus 5. So there's your new numerator there. And then this guy moves down to the denominator, and that factors like your traditional factoring of a trinomial. So r plus 10 times r minus 5. So it's one big fraction. Anything that exists, numerator and denominator, can cross-cancel. So tell me some things that cross-cancel. There should be quite a bit here. R plus 5's gone. R plus 10's gone. Okay, I lied. There wasn't really that much. So up in the numerator, you have a 7r times an 8r squared. You could literally write that down, but that's not quite simplified pre-calc. What is that? That'd be a 56r to the 3rd power. And then down in the denominator, you have an r minus 5. And again, r minus 5 is its own quantity. It's not going to cancel unless you see another r minus 5. Number 5. Skip to number 5, please. Okay, we're adding fractions this time. You cannot add fractions unless they are talking about common parts to whole, which means you need common denominators. So this guy has a denominator of x plus 6, and this guy has a denominator of a totally different number, 5x plus 2. So your common denominator for this question is going to have a list of everything that showed up in the denominator. So for us, that means you need an x plus 6, and you need a 5x plus 2. So this fraction over here, in order to get his denominator to look like that, he is missing the 5x plus 2. And then this fraction over here, in order to get his common denominator to look like that, he's missing the x plus 6. So what I like about these questions is you don't have to do any work on the denominator, because a minute ago I already set it up. So that's all done. But your numerator is this, and it's a hot mess. So let's see what we have here, guys. You've got a 6 times 5x plus 2, so that would be a 30x plus 12. And then there's a big plus sign right here, so plus. Okay, this is bad news. You guys have to multiply x plus 2 times x plus 6 together. So I'm going to need you to FOIL this out. but you're pre-calc. You got this. That's x squared plus, what, 8x plus 12? Something like that. Okay, so good news, bad news. Good news is we're almost done. Bad news is you're not done, I guess. You got to simplify that numerator still. So we have x squared plus 38x plus 24 over, and that denominator never changed. Now, I know some of you are very paranoid right now because you're like, wait a minute, is this one of those weird ones where at the end, like I have to factor and things cancel? That does happen sometimes here, but this is not one of those questions. This is not going to factor any further because that 38 is not going to factor into anything that multiplies to 24. So that's your answer. Fun times. All right, one more. Number 7. Subtracting works the same way. You still need to build your common denominators. And then I need you guys to be real careful here. These denominators that currently exist, they have absolutely nothing in common as far as factors go. So your common denominator is going to have to be a 5b plus 3 and a separate b plus 3. They have nothing in common. So like over here, this guy's going to need the b plus 3. And then over here, this one's going to need the 5b plus 3. Okay, this numerator is going to get some Algebra 2 kids in trouble, and maybe a few pre-calc kids as well. That first part's not difficult. 3 times b plus 3, that's easy. 3b plus 9. But then there's a subtraction sign followed by a whole slew of distribution. So leave the subtraction out for a minute and go ahead and distribute these together. So this would be 5b squared, and then let's see, 25 plus 3, so plus 28b plus 15. And you see where I'm going with this? We're not quite done, because now you have to remember that this was a subtraction problem and subtract all these and then finally get your like terms together. So we end up with a negative 5b squared. Let's see, negative 28 plus 3 would be a negative 25b. Oh boy, negative 15 plus 9 would be a negative 6. I have good news, that doesn't factor, I don't think. And if it does, I don't care because we're out of time. Alright. I'm going to continue this video once you guys leave, and I'm going to go record a few more that were on that side of the worksheet. You guys are supposed to do the other side of the worksheet. But concentrate tonight on studying for that test tomorrow. This stuff is not on the test, obviously. This is just getting us ready for an upcoming lesson. So we're going back to number 2 on the side that is essentially notes. Same idea, you're going to multiply fractions together. So for polynomials, you're going to want to factor everything and then cross cancel like factors. Hey. So this term right here, factors, you can take a 5 out. Over. So then this term down here, you can take out a factor of 6m squared. So let's see, that leaves us with an m minus 4. Don't cancel yet, we'll get there. And then this numerator of 6m squared, that's a monomial, so clearly that's not going to factor at all. But this denominator of m squared minus m minus 6 factors into m minus 3 times m plus 2. So, it's one big fraction now. Let's do some cross-canceling. I see the m minus 4s do indeed cancel, and this is where kids kind of freak out, because the monomials can cancel in pieces. So like this 6 can cancel with that 6, and this m squared can cancel with that m squared, and that's all we're going to see that cancels. So what's left in your numerator is the 5, and then what's left in your denominator is this m minus 3 times m plus 2. There is absolutely no benefit to you redistributing those binomials back together, so we always instruct you guys to leave them in factored form when you get to the end of the problem, because why risk it? Alright, back to number 4 now. We are dividing, so remember we don't actually divide fractions. We're going to change this to a multiplication problem by taking the reciprocal of the following fraction. So lots of factoring here. This is going to factor, and this is going to factor, and this, what will be a denominator, will factor, and that one won't. So, factoring this first numerator, oh boy, let's see, x minus 8 times x minus 9. And then this first denominator, you can take out a common 10. You're going to see a lot of take out the common kind of factoring. That works out nicely in these questions. Now remember, this x minus 9 is now in your numerator. And then down in the denominator, you have, let's see, a common 4 you could take out there. So 4 times x minus 9. All right, so it's one big fraction. Here goes our cross canceling. All right, x minus 8s are gone. One of the x minus 9s cancels with another x minus 9. There's still a third x minus 9 that's remaining in the numerator. It's going to have to stay there. And I think we're done canceling. So you have x minus 9 in the numerator. You have 10 times 4 in the denominator, so we'll call that a 40. And remember, this is a binomial. It's its own term. It's not going to reduce anymore. So there is your final answer. Okay, going back to number 6 now. Common denominators are necessary. Sometimes kids just go old school and use what they call the butterfly method. They just multiply these fractions by each other. And generally speaking, that works out fine. Sometimes you create a really elaborate denominator and numerator that creates lots of factoring later in your problem. So if you're not afraid of factoring, then you can keep doing that method. However, this denominator technically does factor into pieces. It factors into 3 times x minus 4. So I might suggest that you leave it like that. So my common denominator in this question, I'm going to need a 3, I'm going to need an x minus 4, and I'm going to need an x plus 5. So this fraction is missing the x plus 5. And remember, the denominator is already set up. You don't have to do any work there. This fraction is missing the 3 and the x minus 4. So if you want to leave it factored like this, that is totally fine, and that's usually the way I do this question. But if you wanted to go back and call this 3x minus 12, you're still going to get the same answer, same effect. All right, let's take a look at what's going on in the numerator now. This 5x times x plus 5 is a 5x squared plus 25x. And then we have a plus sign, and then here, careful, you have a 6x times 3, which I know that is it's an 18x, isn't it? So that's what I'm distributing into there. So let's see. That would be an 18x minus, oh goodness, is that 72? I never trust myself on that one. Yeah, 72. Oops, this is 18x squared plus 72x. Alright, so again, that numerator needs to be cleaned up a bit. That would give you a 23x squared, squared, yeah. Oh man, 25 minus 72 is a minus 47x. And then that common denominator hasn't changed at all. Now technically, your numerator does factor a little bit. I feel like I made a mistake on that question, so if I did, apologies. You can take an x out of here and here, but since there's no x to cancel in the denominator, by me factoring it, it's not going to have any direct result on the answer. So I'm okay with the answer that we have written down right now, but of course you can go ahead and factor that numerator as well. And again, if I messed up, I apologize. I don't have the answer key in front of me, which is scary. Alright, we got one more here. Common denominators are necessary. Again, your denominator technically can factor into its pieces of 4 times x plus 2. So it's up to you whether or not you do that factoring. Sometimes it creates an easier question, sometimes not. So your common denominator, I'm going to need a 4, I'm going to need an x plus 2, and I'm also going to need an x plus 1. So this first fraction is missing the x plus 1. And then the second fraction here is going to be missing the 4 and the x plus 2. Again, if you wrote that as 4x plus 8, there's nothing wrong with that. So denominator's all set. Don't have to do any work there. But in the numerator, you have, oops, this mess. The left side of it is not too bad. 3x plus 3. But be careful right here. You have a negative, or subtraction, times a 2, times a 4. So if I read that right, we have a subtract 8 being multiplied into x plus 2. So that's the way I'm going to read that part. So I'm going to say that's a negative 8x minus 16. Then, simplifying those like terms, you get negative 5x minus 13, which does not factor, over a 4 times x plus 2 times x plus 1. So these were not the most exciting questions. Didn't have a lot of canceling at the end, which is fine. As long as you remember the process for how one combines fractions together, that's going to get us where we need to go in pre-calc. This is actually not the skill I'm going to be testing you on. Well, we might test on this, but the skill that I really need you to have is just the art of how to get common denominators, the art of how to multiply fractions together, because we're going to need to use those skills in an upcoming lesson. So the other side of the worksheet is what you're doing on your own. Make sure you're showing your work and not just copying the answer key, because that'll be pretty darn obvious with all the work that happens here. If you have any troubles, come in.